So we are on the sheet that at the top says Precal A review 1.5, 1.7, number 2.
No, we've had this for a little while.
All right, so here we go. What have we learned? We've now taken 2 tests in Precal. What have we learned about the correlation between the test and the review sheet? Yes. So we better be figuring out how to do this stuff because you know this is going to be the test questions. All right. Number 1, review, domain. You got to know how to find domain. So here we go. Do any of these have all real numbers as their domain? Is the domain of anything here all real numbers? C is a trick question. It is indeed all real numbers. Now, some of you are looking at that and saying, wait a minute, Mrs. Ford, C has a radical in it. It does, but it's not a square root, it's a cube root. And what's the difference? Well, you can't take the square root of -8, right? Well, you can, but it goes imaginary, right? But can you take the cube root of -8? Yeah, that's actually a doable problem. So the roots that cause us issues are square roots, not cube roots. So that is a trick question, but some of you got it. This C has an all real number domain. X can be anything. There's one more that's all real numbers. E is all real numbers. All right, now everything else has an issue. Everything else either has a denominator. Look at B, letter B, has a denominator. So what do I know about X? It cannot be 3. D has a denominator. X cannot be 2. So everything either has a denominator or a radical. Okay, so look at A. 2 minus X has to be bigger than or equal to 0. Which means X has to be less than or equal to 2. Whatever is under the radical has to be positive. If it's a square root. It's a square root. All right, look at D. There's another radical in D. We already have a part of the answer, but X plus 5 has to be positive, so X has to be greater than or equal to -5. So this is a 2-part answer for D, because it has a denominator and a square root. And then F, what about F? X has to be what? Greater than or equal to -2. So there are your domains. Okay. All right. I'm going to wait on 2. Just leave a little bit of space there. We got to do 7 first. I'm not sure. I can't remember why that's out of order. But go ahead and just leave some space for number 2. We'll come back to it. Number 3. Are these 2 things inverses? Now, on here, I was lazy. I just asked the question. I didn't even put a question mark. But the question will be, are they, and then why or why not? Okay? So, what's your thought on that? Well, if your job is to prove they're not, it's real easy. Pick a number. 10. Stay away from like 1 and 0. Those are kind of special. Just pick some random number. I'll pick 10. If I put 10 in to this function, what do I get? 26. Now, take that 26 and put it into this function. What, if they're inverses, what needs to come out right here? 10. Is 10 going to come out of that? No. So, They are not inverses, so no, they're not inverses. And why? Because their ordered pairs are not what do I want to call that? Flips of each other? Some word, I don't know if that's the best word in the world, but I understand what that means. Now, could I have done a formal proof? Yes. And that's what I would have done if this would have worked. If 10 gave me 26 and 26 gave me 10, that is not a proof. It will disprove, which is what I did, but it's not a proof. I would have to do what I'm going to do in number 2. When I get there, I'm going to do that in number 2. All right, so number 4, find an equation in x and y that represents this set of points. All right, somebody just asked about this. We just did it on our quiz. So what does t equal? X minus 1. So what does y equal? Well, but t is x minus 1. So what does y equal? X minus 1 squared. There is your equation in x and y. That's as hard as it is, people. It is so easy. Number 5, is it 1 to 1? Yes. Why? Passes both vertical and horizontal. Meaning it's a function and its inverse is a function. Good. It is 1 to 1. Maximize the volume of a box. Okay, we know this is question 1. We're going to maximize the volume of the box, cutting out the corners, folding up the flaps. Don't know how big these corners are, but the paper is 13 by 9. Maximize the volume of the box. Okay, what's our equation?
Length times width times height.
Length times width times height, which for this particular problem will be 13 minus 2x times 9 minus 2x times x. Don't forget that x. You need length, width, and height. 3 things. Now, what's your domain? It doesn't ask that on this question, but I promise it's on the test. What's your domain? X has to be between 0 and 4.5. X cannot be bigger than 4.5 or you will not be able to do this. You won't be able to create this if x is bigger than 4.5. So now I type it in on my calculator with the parentheses there nicely. I used a Y max of 100 and it just fit nicely. You could use lots of different things. I hear a calculator coming out. That's a really good thing. Because it drives me crazy when you come in on test day and don't know what you're doing. Because you never practiced. Alright. Every time you do this, you're going to get a point. Your maximum is an ordered pair. So then you have to decide what the answer is. This is not the answer. You put this down, you're going to miss something, like a fourth or something. You need to decide what the answer is. So the question says, maximize the volume of the box. Maximize the volume. So what's the answer to the question? 91.44 cubic inches. This number is your volume. What's this number?
Dimensions.
The size of the corners that you cut out, right?
So you find the maximum, then the y coordinate is your answer?
That's your volume. That's y equals. When you typed it in, didn't you say y equals?
Yeah.
Yeah, that's your volume.
Okay. So our answer is 91.
Yep. To this question, sometimes the answer is the x coordinate. It just depends what the question is. All right, now we're going to find the inverse. And for back to question 2, we're going to prove that we're right for A. Okay, but first let's answer 7. Let's find all the inverses here in 7. So A would be this. Now you can do, that's an easy enough problem. You could do it in your head if you wanted. What would be the algebra steps? Switch the variables. And then solve for y. So your inverse should be x minus 1 over 3. All right, how about the next one? What's step 1?
Switch.
Yep, same as before. That never changes. You're going to switch your variables. Now, you got to solve for y, but it's buried underneath the radical,
Cube it.
right? So we got to get it out of there. So we'll cube both sides. And what happens when I cube a cube root? Disappears. And now I can solve for y. So x cubed minus 1, x cubed minus 1 over 2. There's your inverse. And then the last one is the one like on your quiz. So what's step 1? Switch the variables. That's how we do it. I don't care what the equation is. And there's 2 x's. That's great. That just means there's going to be 2 y's now, right?
Yeah.
So once I get my variables switched, I times, I heard somebody say, you times this over here. And then what? This is the one we forget sometimes.
Put the y.
You gotta get all the y's on the same side. Because eventually, you're only gonna have one y in your problem. You're gonna have to be able to factor to get one y. So you gotta get everything with a y on the same side. So we're just rearranging terms. Now that they're on the same side, we can take it out. And then what's the very last step? So your inverse is 7x plus 1 over 3x minus 2. Okay? Now, okay, so we finished 7. Now I want to pop back up to number 2 because it said check your answer to A. Alright, so let's use the check we used before. This is the original problem. I'll pick a number like 4. If I pick 4 and I plug it in, what do I get? 13. Now I'm going to take 13 and put it in down here. What happens when I put 13 in down here? I get 4. Now, I'm thinking this could be the inverse then because the right thing happened. But it might be that this is just a special situation. Do you understand what I mean? I haven't proven, I proved that it works fine for 4. But I would need to try 5 and 6 and root 7 and every number in the whole wide world to make sure it works for everything, and I can't. So if I'm proving, that's when I build the composition. I'm going to call this one f of x and this one g of x, just to keep them separated. And this is when I build the composition. F of g and g of f. I have to do them both. And do you remember what happens when you build these compositions? They equal x. So I better do this problem, and it better, after I'm done doing all the work, it better come out to equal x. Okay? So here we go. We're going to do this one first. What does this mean? Put g into f. So I called this one g. So I'm going to put x minus 1 over 3 into f, right here. So that'll be 3 times x minus 1 over 3 plus 1. I'm plugging the g function into my f function. Now, see these 3's? They cancel. What do we have left? X minus 1 plus 1, which is x. Which is what we needed to have happen. So now we do the other one. We're going to plug f into g. So we're going to take f and plug it into g. So we'll have 3x plus 1 minus 1 over 3. Plug your f function right here. So 3x plus 1 goes right here. So what's plus 1 minus 1?
0.
0. So I'm left with 3x over 3, which reduces to x. Now I have proven it. If your job is to prove, if you're saying, yes, these are inverses, and you're asked to prove it, then you need to build these compositions. Doing the ordered pair is only enough if it doesn't work. If you put in 4 and get 13, and then you put in 13 and get 6, you can say no, they're not inverses. Okay? Got it? All right, number 8. If n of 5 is 11, then n inverse of 11 would be, we just talked about it, 5. Yep. Yep. If they're inverses, that happens. If they're inverses, that is exactly what happens. All right, now we're going to do some sketching. So we're going to graph this one and this one. Now, some of these you guys can probably do in one step, but it looks like they all have a couple of things going on. Well, B doesn't, but all the rest of them have at least 2 things happening to them. So if you want to do them in 2 steps, that's absolutely fine. What are the 2 things that are happening in this problem? What are we doing to our picture?
Making it longer.
We're turning it upside down, and we are making it twice as tall. So looking at the original, see the original has that triangle that's going down, and it's going down to, you see what I'm talking about? The original has a triangle right here that's going down to. What's going to happen to that triangle? It's going to be flipped up, and it's going to go up 4 because it got doubled. So that triangle is going to look like this. Remember, this is taking you upside down, and this is making you 2 times as tall. Multiplies the vertical, makes you twice as tall. Now, how about this bar right here? He's going nowhere. What's his height? 0, right? Double it, it's still 0. That's going nowhere. But what about that? I guess that's a circle. What about that circle right here? What's going to happen to him? He's going to go down, and instead of going down just 1, he's going to go down 2. So that would be a picture of the first one. All right, this one only has one thing. What is happening in this picture? It's going to be twice as wide. This number divides the horizontal, kids, and dividing by 1/2 is the same as timesing by 2. So it's going to be twice as wide. Not flipped over or anything like that, just twice as wide. All right, so here we go. See that V? How wide is he in the original? 2. So now he's going to be 4 wide. Still down 2. We didn't change the height of it at all, just the width. Now what about our bar? How long is our bar going to be? Now he'll be 2 units long. Everything horizontally is getting doubled. How about our little semicircle? He did have a diameter of 2, now he'll have a diameter of 4. So there it is, twice as wide as it was before. The next one is where things get freakish for me. I'm probably going to do this in 2 steps. You are younger than me, so you can probably do it in 2. I can't keep track of all that, so I'm going to do this first. What does that negative do?
Switch sides.
That switches sides. Switches sides. Y-axis. So this is going to flip across Y-axis. All right? So what that means is, I'll just dash it in. What that means is, my triangle's over here. My bar is over here. And my semicircle is over here. Oh, I was going to dash it. Okay. That is a picture of nothing more than the flip. Is that okay with everybody? Now, what else do I need to do? What does that number do? Shift it down 1. So every point is going to come down 1. So what that means is, my bar is going to be here now, right? My bar is going to be down here. And my circle is actually going to be tangent like that. Everything went down 1. Here's another one I'm going to do in 2 steps. What happens when I take the absolute value of the whole thing?
Oh, it's absolute value.
Anything
everything
negative
positive?
becomes positive. So anything on the bottom of the picture is going up. So first thing going up is that little triangle right there. He's going up. The bar, of course, is not changing. And the circle isn't changing either because he's already up. When you take the absolute value of the whole thing, all that happens is the negative parts get folded up. So that's that much. Now, what do I have to do?
Move it up.
Up 1. So every point is coming up 1, so my bar is up here now. And there we go. There's your answer. Okay, we already answered number 10
Can
when
we
we
do
did the
E?
problem. What?
Can we do E?
Oh, I didn't see E. Sorry about that. We already did number 10, but we didn't do 9E. Write the equation for this curve. So now I'm backwards. I have drawn a picture and said, okay, what numbers, negatives, absolute values, whatever, would go into the problem to make it look the way it looks right there. All right, so let's just make a list of what changes you see. Look at the original, look at the one I drew. What are some changes you see? It's flipped over the x-axis. All right, so we'll have to figure out what we're going to do to make that happen. I think there's another change. Half as tall. So here's my equation, y equals f of x. I gotta stick some stuff in here that's gonna accomplish this. All right, what will flip you over the x-axis? A negative. A negative where? Out in front. That's gonna flip you upside down, which is what happened in this problem. That flipped us upside down. Now what's gonna make you half as tall?
1/2 outside.
A 1/2 outside here. That would make you half as tall because that number multiplies the height, the vertical. There's your equation right there. I think it helps to make a list of the changes and then go back and put in whatever you need to put in. How many ounces of lemonade? Well, we talked about this yesterday. You can use whatever format you like. I'm going to use this one every time because it works and it's easy. Amount times percent plus amount times percent equals amount times percent. I'm going to plug in my percentages. They're always given, so it works out great. I need 5% lemonade. Remember, 5% is 0.05, and 12 is 0.12, and 8% would be 0.08. So there are my percentages. Now, I will always, always have one amount given. So what is the amount I have? 8 ounces right here. I do not know this amount, so I'm going to call it X. I'm mixing X and 8. So how much am I going to end up with if I am mixing together X ounces and 8 ounces? How much am I going to have? X plus 8. Not 8X. I'm adding them together, so it's X plus 8. So 0.05x plus, double check my arithmetic, I'm doing this on a calculator, which is crazy dangerous for me. This would be 0.96, wouldn't it? Yeah. Okay, so negative 0.03x equals 0.32. Double check, is that right? Negative. So whatever 0.32 divided by 0.03 is, I got 10.6 repeating ounces. Anybody match that?
Yeah.
All right, on my daily 5-mile walk, I try to jog 1.5 miles of it. What percent of my journey is spent walking? How far do I walk? No. Part of that's jogging. How much of it's actually walking?
3.5.
3.5 miles. So how do I find the percentage? 3.5 is what percent of 5? What do I have to do? Divide. So the answer is simply whatever 3.5 divided by 5 is. That will be my percent. And it's 70%. And finally, a cylindrical tank has a diameter of 12 feet. Okay, so a cylindrical tank, so that's a cylinder. Here's my cylinder. And it has a diameter of 12 feet, which means the radius is 6. The water in the tank is 6 feet deep. Water is leaving the tank at a rate of 4 cubic feet per minute. So like there's a spigot down here or something, and water is coming out at a rate of 4 cubic feet per minute. Write an expression for the volume in T minutes. So T will be the number of minutes. Water's in the tank at the beginning. Before we open up the spigot, how much is in there?
6.
Well, volume is pi r squared h, right? Okay, so I have pi r squared is 36, and h happens to be 6. Now, that's not the height of the whole tank. That's the height of the water in there. That's how much water I have. So what is that, 216 pi? Now, that's how much water is in the tank right now, okay? So here sits the tank. It's got 216 pi cubic feet of water in it. Now, I twist the little nozzle, and water starts pouring out. In the first minute, how much water comes out? 4 cubic feet. In the first 2 minutes, how much water comes out? 8. So in the first T minutes, how much water is going to come out? 4T. So the answer to the question is right here. It's what you started with, 216 pi, minus 4 feet every second. So T, or minute, if T is the number of minutes, then 4T is the amount of water you're going to lose. So 216 pi minus 4T. Now listen to me. That was review 2. It is now done, right? You may want to go back and review or whatever, but it's done. Practice test is done on another video. So sometime I'm going to do review 1 in some other class, and it will be on video. Take advantage of these worked out solutions, people.